Assalamualaikum. My name is Khairi Jasmi bin Jasman and my matching number is AA232018. And we are from Group 10. We'll present a topic from solid mechanic, which is about a workbench.
Assalamualaikum warahmatullahi wabarakatuh. My name is Najmi Izzuddin bin Fairuz, metric number AA230689. So I will explain about our introduction. So my group chose workbench for our group project. A workbench is a place where work is carried out, and our objective is to calculate the load on the legs of the table and to calculate the moment, inertia, and stress experienced by the table. By calculating this, we can improve the table itself.
So this is the structure and the dimension of the workbench that we have built using SolidWorks.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Taufiq Hakimi bin Jamil with matrix number AA231745. So our objective is to calculate the normal force, shear force and bending moments, moment of inertia, and the maximum tensile and compressive stress experienced by the table boards. And we want to calculate the torsional stress on the wheels, and we want to calculate the moments on the inner beams.
So the first step we need to calculate is the normal force that have been applied into each of the workbench leg. So we have given the length is 2.080 meter and 0.880 meter, and the height is 0.050 meter. In order to calculate the force, we need to calculate the load, which is volume multiplied by the density. In order to get the volume, we must multiply each of the length and the height, and we get 0.09152 meter by power by 3, and the load is 0.09152 multiplied by 900, and we get 82.368 kilogram, and we multiply by 9.18, which is the gravity, and we got 808.03008 Newton. And in order to find the force in each leg, which we have, the workbench, we have 4 legs, and the force is spread equally in all area, which we will be divided by 4, and the answer we get is 202.00752 Newton.
Assalamualaikum. My name is Muhammad Marifki bin Muhammad Azlan with number metric AA231307. So I will explain the shear force and bending moment. So the given load is 200 Newton, and for each table legs force is 202.00752 Newton. So with x is 0 to 1.04 meter, the V we will get is 202.00752 Newton. The moment we get is counterclockwise is 0 to 210.088 Newton meter. And for X, 1 to 1.04 to 2.08 meter, the V is 2.00752 and Newton. The moment is the same as the first one, which is it will be negative. It will be 0.
Now back for my part. I'll be presenting about the calculation of moment of inertia on the table board. As you can see, the length of the table board is 880 mm and the height is 50 mm. Since the table board is in perfect rectangular shape, I assume the neutral axis will be its center, which is 25 mm. And then I conducted the calculation using the formula I is equal to BD square over 12 plus AH square, which is appeared on the slide. And then I get the final answers, which is 3.1 3.416666667 times 10 power to the power of negative 5 meter power to the power of 4.
Now we're gonna calculate the maximum tensile and compressive stress experienced by the table board. So we use the formula sigma equals to mc over I, which means stress equals to moments times distance over inertia. So we know the moments that we have calculated before, which is 210.088, and we know the inertia, which is 3.4167 times 10 power negative 5 meter quadratic. Now we're gonna find the C, which is distance from neutral axis to outermost line, and we get 50 millimeter minus 25 millimeter, and we got 25 millimeter, and we change it to meter, and we get 0.025 meter. So we just fill this number into the formula, and we get stress equals to 153.72 kilopascal.
Okay, now for the moment of inertia of the inner beam. The inner beam is as shown on the slide. Okay, first of all, I use the method of composite to find the neutral axis or the center of these all three shapes combined. Next, for each section, I use the formula of inertia, which is BD square over 12 plus AH square. Which the calculation is shown in the slide. And then the final inertia I get by summarizing all the section inertia is 176.66 or 176,666 and 66 millimeter to the power of 4.
Okay, next we will move to the wheels calculation. So first we will use formulation top formula, which it will be force multiplied with radius. So the diameter of the wheel is 38 millimeter. So we will convert it to meter, and then it will be 0.019 meter. So the final answer of torque is 3.838 Newton meter. So next we will use torsion, formula torsion. Torsion formula is torque multiplied with radius over J. So first we need to find J. To find J, we will use formula pi d power of 4 over 32. So the diameter is 0.038 meter. Then we will get the answer of 2.047 multiplied with 10 power of negative 7 meter power of 4. So next we will use torsion formula, and then we will use the answer that we have searched, which will mean it will be 356.24 multiplied with 10 cubic Pascal.
Next, we move on to the conclusion we got. The workbench can be analyzed by calculating the load on the table leg, board, and beam. By calculating this workbench, we know why they are designed like that. So we can identify area for improvement to enhance the table stability, durability, and the overall functionality.